Today, let's see how to document the R scripts and save the codes along with the outputs in a readable format, such as PDF, HTML, or Word. This can be done using the R Markdown feature under R Studio.
Hello friends, welcome to our YouTube channel Statisticians Hub. Today's video is on distribution fitting for parametric survival analysis in R. Let's start with this topic. Two of the things which first should be known are survival analysis and the importance of distribution fitting. So what survival analysis is? It is a statistical technique to analyze the duration of time until an event of interest occurs. It considers the censored events as well. The need for fitting of a distribution is to predict the probability and forecast the occurrence of future events. Different characteristics and parameters of the data can be approximated, which is crucial to understand the analysis. The dataset for this study is a football data for a team scoring a goal against the opponent. The survival event of concern will be the goal scored by the team within the first 90 minutes of the match. If the team fails to score a goal within the first 90 minutes, it will be the case of censored events. Now let us check the data set. Here the first column is the time variable and the second column is the status, where 1 in the status stands for the happening of the event and 0 stands for the censored case. Well, the distribution fitting to the data set shall be considered in the R software. Package called FlexSurf package will be used as it provides a platform for the fitting of parametric distribution. So what is FlexSurf package? It is a R package for fully parametric modeling of survival data. Any parametric time to event distribution can be fitted if the user supplies the probability density or the hazard function and also the cumulative versions. Standard survival distributions are already built in this package, such as the exponential, Weibull, log normal, log logistic, etc., including the 3 parameter and the 4 parameter generalized gamma and the F distribution. Another important feature of the FlexSurf package is that it provides us the platform to fit any distribution in the custom method. So further in this video, what we are gonna do is that a 2-parameter Weibull distribution will be fitted to the dataset. Firstly, by using the built-in feature of this package. The same distribution will again be fitted using the custom procedures, like if that distribution is already not a inbuilt one in the package. And later the generalized exponential distribution, also known as the exponentiated exponential distribution, will be fitted to this dataset. For fitting the Weibull distribution in a non-custom way, firstly we're gonna call the following packages. If these are not installed, these should be first installed and then called using the library function. The 7 packages are run in R Studio. Then we call the dataset and fit the distribution to this. Firstly, for calling the dataset, we use this following command. Then we specifically define our variables and combine this for the survival data. Later, we use the Weibull command code and fit the distribution to the dataset. Here is the command in R and the output is as follows. Here we can see the shape parameter and the scale parameter are being estimated along with the AIC value. For plotting the distribution to the survival curve using ggplot, firstly we are going to calculate the survival probabilities of the Weibull distribution using the given estimates. Firstly, the scale and the shape estimates are given in R. Then we define the time points and the survival values using this command. And then we fit this in the data frame. So here is the output of the survival probabilities of the Weibull distribution at different time points. For plotting the distribution, firstly we fit the survival curve using these two codes, and then the Weibull distribution is fitted as a geom line. Here is the output. Now, if the same distribution is fitted in a custom way, firstly we install and call the packages, attach the dataset and fit the time and event variable to the survival data, like the previous method. Then we fit the distribution using the custom method. For custom method, we first define the hazard function, and then we define certain name, parameter, location, and the initial variable along with the transformation and the inverse transformation. We fit the Weibull distribution like the previous one, and running the code in R, we get the following output. So from the values, we can see that the parameter estimated values are same like the previous method, and also the AIC same. The output is same as the previous one. Now, if we fit the generalized exponential distribution, firstly, the necessary initial codes like the calling of the libraries and calling of the data set, fitting the specific variables to the survival data are same. The custom code is same, almost same, the pattern like the Weibull distribution. Here we first define the hazard function of the generalized exponential distribution, and then we define the parameter, location, and other things. Running this code in R, we get the following output with the shape parameter and the scale parameter. The AIC value is 480, which is slightly more than the Weibull distribution. For plotting technique, here we have not used the ggplot, but the general plotting techniques. And this is the desired output. So this is for this video. Thank you so much.